MAT 1122 Differential Equations 1 Lesson 3 Linear Differential Equations of the First Order. If you consider the equation of the form dy by dx plus py equals q, here p and q are the functions of x, but those are not functions of y. So if the given equation is in that form, we call that equation is the linear differential equation in the first order, right? As an example, if we consider this example, dy by dx plus 1 over x y equals x to the power 2. So this is in that form, dy by dx plus py. What is p here? P is equals to 1 over x, that is function of x, times y equals q equals x squared there. So it means q is also the function of x, because that is x squared. P is 1 over x, both are functions of x, right? So we consider that simple example is dy by dx equals 1 over x y, sorry, here plus dy by dx plus 1 over x times y equals x to the power 2. By comparing, or we can write this equation is in the form dy by dx plus py equals q, right? Here p equals 1 over x and q equals x squared, both are functions of x. It means this is linear differential equation. Therefore this is linear differential equation. So this is linear differential equation. Okay, so we are going to simplify this equation. So you can see I am going to multiply whole equation by x, by multiplying x. So what happened there? X times dy by dx plus, if you multiply this by x, that's come y equals x cube, right? So if you carefully observe this part, this is d over dx times xy. How it's come here? If you consider d over dx times xy, if we differentiate this, x times differentiation of y dy by dx plus y times differentiation of x, that is 1. It means this part, no? So it means we, if it is in that form, we can write this. Okay, so then you can write, we can integrate dxy equals integration of x cube dx. So here we can write xy equals x cube, if you integrate x to the power 4 over 4 plus c, where c is an arbitrary constant, right? Where c is an arbitrary constant. So if we multiply this by x, what happened? This equation is reduced to that form, right? It means a production of two terms, right? It means my integration factor and y, that is a multiplication of integrating factor and y. If it is become that form, if you multiply it by a certain number, right? It means like this way, certain term. So we call this as integrating factor. Integrating factor, right? It means if we have a equation in the linear form, so we can use the integrating factor, then multiplying it, then we can easily simplify that equation. So there are several there is a method to find the integrating factor, so we will discuss that in next. Okay, so now we simplified this one, and hence integrating we got this answer xy equals 1 over 4 x to the power 4 plus c, where c is an arbitrary constant. So it means here the x is the integrating factor. Let us try to find the integrating factor for the general case, right? So now we are going to consider a general case to find the integrating factor. Okay, integrating factor in general case, right? We will consider dy by dx plus py equals q. You know that here where p and q are functions of x. So this equation, you know that this p and q are the functions of x, right? So we assume that r is the integrating factor, right? Integrating factor. So we assumed r is the integrating factor. Then what happens? If we take an integrating factor, if we are done in the previous example, we have to multiply whole equation by this integrating factor plus r times p of py equals rq. Then what should be here? So if you multiply this by integrating factor, it should be reduced to d over dx times integrating factor times y, no? Here it's come there, no? Here integrating factor times y. So if we consider general case, it should be reduced to that form. Okay, but we know that this part, since d over dx ry, so if we differentiate that, what happens here? We'll see what happens there. This we can differentiate r times dy by dx, right, plus then y times dr over dx, no? So I simply differentiate this part, right? So then this should be equals to this one, no? Therefore we can write r times dy by dx is plus this part r py. This is identical, right? Identical to this one, r dy by dx plus y dr over dx, right? R dy by dx r equals, so we can get, therefore r times py equals y times dr over dx. So y can be cancelled, so rp is equals dr over dx, right? Now we found rp over is equals dr over dx. Now what we can do is, now we can separate in the terms, right? Here we know that p is the function of x, so I am taking p for this side, x for this side. P times dx equals 1 over r times 1 over r times dr. Now I can integrate both sides. Then here integration of p dx equals 1 over r times dr means ln r, no? ln r plus c, where c is an arbitrary constant, right? Here we set c equals to 0. C is an arbitrary constant, no, it can be 0 also. Then p times dx equals ln r. Okay, then we are taking e to the power integration of p dx, right? Then e to the power ln r, ln and e to the power cancel, then e to the power integration of p dx equals r. So we get r as integrating factor. So how we can find the integrating factor? That is, so we assume r is the integrating factor, right? Then we found the answer for the r is e to the power integration of p dx. So that is the general case, so you have to remember this formula. This is a way of finding the integrating factor. Okay, so then that is the rule. Then you have to remember this rule. What is it? To solve, I think it is in the presentation, so we will, right? So we found, yes, r equals e to the power integration of p dx. Then this is the rule. This gives a rule to solve dy by dx plus py equals q. So to simplify this kind of linear differential equations, what you have to do, you have to multiply each side by integrating factor. It means e to the power integration of p dx, then that is the integrating factor. Okay, now we will consider the same example which we discussed in earlier. So we discussed this example, so I am taking this one. So if we multiply this by x, so we didn't found the x, we just taken at x and multiply, then it is automatically converted into this form. But it is difficult to think and do this, so we have to use this method. So I am taking the previous same example again, and we'll see what happened. Example, right? So what is the example? dy by dx plus 1 over x, y equals x to the power 2, right? So we can write this is a linear equation of the form, what is the general form? dy by dx plus py equals q, where here p equals 1 over x and q equals x to the power 2. When compare these two equations, p equals 1 to the power x, q equals x squared. So then we can find p dxy, because we need this part for finding the integrating factor. So we can integrate this. P means 1 over x times dx equals ln x, no, that is ln x. So then we can find the integrating factor equals e to the power integration of p dx. Then e to the power integration of p dx means ln x. So e to the power ln x means x. So what is the integrating factor there? X. So earlier also we took that as x, so but we didn't find it, right? So before multiplying, you have to find the integrating factor by using that method, right? After finding the integrating factor, you can follow the similar steps to find the answer. So I am not going to explain that part again because this is the same question. So this is the way of finding the integrating factor. Earlier I didn't tell you how to find the integrating factor. Now you can find that. Okay, so I will then example 2, right? So then lnx, this is the integrating factor. Example 2, dy by dx plus 2xy equals 2 times e to the power minus x squared. So we will consider that example also, right? Example 2, dy by dx plus 2xy equals 2 times e to the power minus x squared. This is a linear equation in the form, what is the form? Dy by dx plus py equals q. Here where p equals, here p is 2x and q equals 2 e to the power minus x squared. So first we have to find the integrating factor. We have to find p dx. Integration of p means 2x times dx. So 2 times x dx, that is equals x to the power 2 over 2 multiplied by 2, then that is x squared. So then we can find integrating factor, that is e to the power minus p dx, sorry, e to the power integration of p dx. Then integration of p dx means x squared, right? We found the integration factor. Then what you have to do is by multiplying integrating factor. So we have to multiply all by integrating factor. So this equation, so e x to the power 2 dy by dx plus 2 times x to the power 2 y equals, here minus 2 x to the power 2. It means if we multiply ex to the power 2, here remaining only 2, right? So then this is reduced to that form, no? D over dx times ex to the power 2 y equals 2. We will consider that is correct or wrong. Ex to the power 2, that is in there, differentiation of that part dy by dx, right? Plus y times y is there, in differentiation of this part ex to the power 2, that is here, then differentiation of 2x squared 2x, yeah, that is we can write in that form, no? That's correct. Then what you have to do is, then you can integrate this separation by separating variable e x squared y equals 2 times dx. So what is this? Ex to the power 2 y equals 2x plus c, where c is an arbitrary constant, right? So then we can subject y, so y equals 2x plus c, if you send this to the other side, minus x squared, no? Minus x squared. This is the answer, right? So so if we consider this part, yes, we found integrating factors p equals 2x, and then we can so we found p equals 2x, then we can take the integrating factor, that's p times dx equals x squared. So then we can multiply in both sides by the integrating factor, then we can take the answer as y equals 2x plus c times e to the power x squared, right? Example 3, right? Dy by dx plus 3y equals e to the power 2x, right? Example 3, right? Dy by dx plus 3y equals e to the power 2x. This is a linear differential equation of the form, what is the form, dy by dx plus py equals q, where p equals 3 and q equals e to the power 2x. Right, then we have to find the integrating factor. Before that we have to find the integration of p dx equals 3 times dx. No, p is 3, no, then that is 3x. Now integrating factor, we can find what, e to the power integration of p dx, that is e to the power 3x. Now what you have to do is you have to multiply whole equation by integrating factor by multiplying the integrating factor, So if you multiply whole equation by integrating factor, what happen, e times 3x times dy by dx plus 3e 3x times y equals e to the power 2x multiplied by e to the power 3x, that's come e to the power 5x. Right, so now we can write this is d by dx. What is integrating factor? E to the power 3x times y equals e to the power 5x. We'll see our calculations are correct. First we have to differentiate e to the power 3x times dy by dx, here that term is correct. Then y times e to the power 3x, here y times e to the power 3x, then differentiation of 3x is 3, yes, that is correct. Now we can separate the variables and integrate this. So d e to the power 3x y equals e to the power 5x times dx. So e to the power 3x y equals e to the power 5x divided by 5 plus c, no, where c is an arbitrary constant. Right, so then we can subject y equals 1 over 5 if we 1 over 5 if we divide this by e to the power 3x, here remaining e to the power 2x plus c times e to the power, if we divide this it's come minus 3x. So this is the answer. Okay, so yeah, we got that answer, e to the power y equals e to the power 2x over 5 plus c plus e to the power minus 3x. Okay,